Which of these structures has carbon atom with the highest oxidation number? Here's ethanol. So you can figure, let me help you figure out the oxidation number of this first carbon right here. Which one's more electronegative, carbon or hydrogen? Carbon. One mnemonic that I made up for myself to remember the sequence of electronegativity is FONClbrisch, at least the common nonmetals. So I just remind myself of this. I try to pronounce it, make up a word or phrase from it. Phone call Brish. Okay. So hydrogen is less electronegative than carbon. This is 2.2 or 2.1 depending on what you're looking at, which textbook you're looking at. I think let me see. Pauling's original number was 2.2, but in 1961 he changed that to 2.1. And fluorine, of course, is 4.0 on that scale, right? So those are the most electronegative atoms. So carbon is more electronegative than hydrogen. So according to this sketch right here, okay, how many electrons belong to this carbon atom right here? It owns all of these 6, right? Why? Because it's more electronegative than hydrogen, and it owns half of this pair because carbon and carbon you have the same electronegativity. So this carbon right here appears to own 7, right? Now a normal neutral carbon atom by itself would have how many valence electrons? 4 valence electrons. It belongs to group 4A, right? 1s2, 2s2, 2p2. In the valence shell, there's 4 valence electrons. 4 electrons. So 4 minus 7. So this carbon appears to have gained 3 electrons. So we say the oxidation number of this carbon is -3. Okay? Can you quickly tell me what's the oxidation number of this carbon right here? It's -3, just like the other one. How about this carbon right here? Also -3. Let's try this carbon right here. The second carbon. Okay. Does it own these 2? Yes. How about these 2? Yes. How about this? Half of it, right? So 1 of that. What about these 2 right here with the oxygen? It doesn't own that. Oxygen is more electronegative than carbon, right? So that doesn't belong to carbon. So this middle carbon right here, or this second carbon, how many does it appear to own then? 2, 4, 5, right? So 4 by itself, on its own, -5, it appears to have gained 1 electron. So the oxidation number of carbon here is -1. Okay? So let's take a look at the other 2. And so which of these structures has a carbon with the highest oxidation number? Is it A, B, or C? Think about it or try to figure it out. You just need to figure out the last 2, right? This one right here and this one right here. This carbon right here. What would it be? How many does it own? It owns those and those. That's 4. Does it own any of this shared with oxygen? It doesn't own any of those, right? So these, huh? Oh, that's right. Only 1 of those. Correct. Very good. So it owns that, and it owns 1 of these 2. So that's 3, right? So 4 minus 3, oxidation number is +1. Okay? How about this carbon right here? This one now belongs to oxygen. These 2 pairs belong to the oxygen, so it only owns half of that pair. So here it only owns 1, right? So 4 minus 1, it now has an oxidation number of +3. It appears to have lost 3 electrons. Here it appears to have lost 1 electron, and here it appears to have gained 1 electron in comparison to the neutral atom. So correct answer is C. Okay? Now, take a look at this. This is actually what happens to wine when it sours. Ethanol, that's what gives you the hangover when you drink wine, right? CH3CH2OH. When it turns sour upon exposure to air, okay, we say it is oxidized to acetic acid. Sour taste, same sour taste in vinegar. Okay, so that's acetic acid. So from what was the oxidation number here? -1 to +3. An increase in oxidation number is oxidation. Okay, this happens when this reacts with oxygen. Another way of looking at it is you're bonding your carbon to more oxygen. See, this is just bonded to one oxygen here. Okay, it's sharing with oxygen. Here, there's more sharing with oxygen. The more an atom shares with oxygen, unless it's fluorine, which is more electronegative than oxygen. In general, oxygen is the second most electronegative element, right? The more an atom shares with oxygen, we can say that the more it's losing electrons. So combining with oxygen means losing electrons, so that's getting oxidized. In fact, the original uh, meaning of oxidation is reacting with oxygen, but although it's now been generalized to the process where you're losing electrons. Because in general, when an atom combines with oxygen, it loses, in a way, it loses electrons to the oxygen. So if you look at structures like this, you can just look at if you're going from an alcohol here in ethanol to acetic acid, which is an example of what's called a carboxylic acid. You have more bonding of the carbon to oxygen. That's an oxidation reaction, half reaction. Okay.